Well, good evening, Brian. Tonight we are going to look at quiz, what was it? Quiz 6. Quiz 6, which is over sections 2.4 and 2.6 in your textbook. The big topics here are maximization and the rational root theorem. So we'll talk about those. Um, so say you want to maximize the amount of bacon maple voodoo donuts that you can put into a cardboard container that looks something like this. It doesn't have any top on. So this is just the bottom part of a cardboard box. And you want to fit as many donuts into this box as possible, saving money that your company would spend on the cardboard itself. So let's unfold the box and see what that looks like. Look something like this. And then let's just call this dimension x. I didn't draw that very well. Let's say that these are even and they're the same. So that's x, that's x, that's x, that's x, that's x, that's x, and then another one there. So when you unfold this top box here, it looks like this. You would have fold lines right there. And you'd have a fold line right there. So that would fold up. And that would fold up. And you could leave tabs on there somehow to tuck them in and keep them secure, whatever. But this is your basic container. So we need some kind of dimensions on here. Let's say that the entire distance from here to here is 40 centimeters. And the entire distance from here to here, let's say that's 60 centimeters, a little bit longer. So then let's write an equation for the distance from this red point to this red point right here, noting that the distance here is x and the distance here is x as well. So this distance here would be 60 would be the whole thing, but we would have to eliminate this x and this x. So that would be 60 minus how many x's? You guessed it, 2x. And then the distance, let's use another color, between this green point and this green point down here. You know, if I were really cool, I would make that red too, 60 minus 2x. And then the green points here, this would be 40 minus 2x. So then if we were doing our container up here, the length of the container would be 60 minus 2x, and the width of the container would be 40 minus 2x. And the height of the container is just x. Should make that, I guess, black. How about? So then if we were trying to write an equation for volume of the container with respect to its height, x, we would say that that is the width times the height, x, times the depth. Okay, so the only one we know is height. Actually, I guess I could say height in there, but it's width times height times depth for a three-dimensional volume. So let's extend that to something a little bit more specific, because we do know more. So the volume with respect to the height x would equal, what was the width? 60 minus 2x times x. What was the depth? 40 minus 2x. So let's multiply some of those out. And probably it'll be a little bit easier if I do the x last. Doesn't matter really, but it might be easier if I do the x last. So then I'll go these in parentheses, 60 minus 2x times 40 minus 2x. Let's go like that. So that gives us V with respect to x, volume with respect to x equals x times 6 times 4 is 24 with a couple of zeros is 2400 minus 2 times 60 is 120. So negative 2x times 60 would be negative 120x. 2 times 4 is 8, so 2 times 40 is 80, so negative 2 is negative 80. Negative 2x times 40 would be minus 80x. And then we would have, I'm going to move all this over just a smidge so we have a little bit more room. There. So then we would have minus 80x, and then negative 2x times negative 2x would be a positive 4x squared. Don't forget to do 2 times 2 and x times x. A lot of times people forget about the 2 times 2. So then let's distribute the x to everything here. So then we have the volume with respect to x equals 2400x minus 120x squared minus 80x squared plus 4x squared. Let's simplify that a little bit. The volume with respect to x equals 2400x minus 200x squared plus 4. Oh wait, something went wrong. No, I am so sorry, Brian. I put x squareds on there and I shouldn't. Those are just, or are they? X squared. Oh, I know what I did wrong. I know what I did wrong. This 4x was x squared, and now it should be x cubed. See? Mistakes are okay. So if we go, let's double check. X times 2400 is 2400x. X times negative 120, that's x squared. X times 80x, that's x squared. And x times 4x squared, that's x cubed. You might have already caught that, but that's okay. That's why we kind of check these things. 2400x minus 200x squared plus 4x cubed. Yes, that is right. Because it's a volume, this has to be cubed. This has to be a third degree polynomial. Okay, so now if we had the calculus, then we could solve this. But we don't have calculus yet. I want to take that first derivative, but we don't have calculus yet. So in this case, the only thing we can do is graph it. You could graph it by hand, or you could bring a calculator in, which I'm going to do here. And I'm going to clear this. I'm going to go quit here. All right, so now we have our calculator out. I'm going to save this one for later. I'm just going to go on top of the equal sign and hit enter and turn that off. Go down here where I can see. And then I am going to put in this equation right here. So 2400x minus 200 x squared plus 4x cubed. Okay, that looks pretty good. And notice these numbers are going to get big. The x's, however, can only be between, well, let's see, it was 40 and 60. So the smallest x I could have would be 0. That would be a completely flat, um, a flat two-dimensional piece of cardboard with no height and no volume. And then the biggest x I could have would be 20, which would be half of this. So that's it. That side there is what controls this. So when I do my window here, I'm going to go from an x min of 0, go up just a smidge higher, x min of 0, x max of 20. I think I'm going to make a mark every 2, I guess. I just do 10%. And then my y, I got to think about this one a little bit. If this is 20, which it won't be, let's do 10. Let's go right in the middle. 10 cubed would be 1,000, so that's 4,000. 24,000 there minus, that would be 100. So that's 20,000. 24,000 minus 20,000. That's 4,000 plus 4,000. So maybe 10,000. See, so this y scale we really need to change. So we can go from 0 to 10,000. And this is important that you have a sense of this. And again, I go 10%. So I'm going to make a mark every 1,000. And these are cubic centimeters, so they're little. An x resolution of 1 is fine. We don't have to worry about that. So at this point, make sure I have that in there. It's turned on. It's ready to go. We should be able to graph it. And sure enough, there it is. Okay, it was good. So, and you may not have this kind of awareness right away, but you can fiddle around with your window until you can see this high point here. And then all we have to do is go second, calc, max 4 to maximize it. Left bound, take it over here. Hit enter. Right bound, take it over here. Go past the maximum point. See, my maximum point is there. So I'm past, it's already going down. It has to be between there and there. Hit enter. Now I have my 2 markers, and I can go back just a little ways and hit enter, and it will calculate. My x needs to be about 7.847 centimeters, and my y will be 8,450-ish cubic centimeters. So the maximum box will have a height of about 7.8. I want to say 7.85, but I'm just going to go 7.8. I guess that would actually round down. About 7.8 centimeters. And volume would be, I lost my calculator. What a bummer. I can't even remember what that was. I guess I better bring it back. 8,450. Volume would be approximately 8,450 centimeters cubed. And there you have it. And you can figure out on your own, if you want to, Brian, the dimensions of the rest of the box. You know, obviously you could go 60 minus 2 times 7.8 and 40 minus 2 times 7.8 to get these other dimensions. I'm not going to worry about that right now because I'm 15 minutes into this video, so I want to knock out the next one maybe a little bit faster. So that's a maximization problem. Now, we've had, I'm going to switch gears now to a rational root theorem type problem. For instance, a problem might say something like solve 3x cubed plus 8x squared equals 9x minus 2 using the rational root theorem. Okay, so first thing you got to do, step one, is to write it in standard form. Standard form, which is ax cubed plus bx squared, so like that. 3x cubed plus 8x squared minus 9x plus 2 equals 0. Here's standard form. So then, in the rational root theorem says if x equals p over q, there's some other stuff too, but I won't give you ones that don't work, is a rational root, then p over q might be, so we got to think about that a little bit. So what are factors, and which one's p and which one's q? That's another thing. So a sub 0 is p, this one here, 2, and a sub n, the coefficient here, 3, not this 3, and this 2 is q. So we've got to think, well, what are the factors of 2? Well, 1 and 2. But we can't just say 1 and 2. We have to say, well, it could be negative 1 times negative 1. So we'd have to say plus and minus 1 and plus and minus 2. And what are the factors of 3? And again, plus and minus 1, plus and minus 3. So then, p over q, I should probably put this down. P over q might be then, okay, so 3, this one, I'm going to cheat here. This one is q, this one is p, so they're in the right format. So p over q might be plus and minus 1/3, plus and minus 1 over 1, which is just 1, plus and minus 2/3, and plus and minus 2 over 1, which is just 2. Okay, so at this point, it might seem like guess and check, but let's talk about it more in terms of like testing these possible factors. It's not really like guessing, because you know what they are, and we're just going to test them using good old synthetic division. Okay? Synthetic division. So, all right, let's try 1/3. So, we will write down 3, 8, negative 9, and 2. Now, notice that this is a third degree polynomial, and everything is right in order. 3, 2, 1, 0 in terms of the degree of the polynomial. I really want to note, if there was not an x squared term here, like if it just said 3x cubed plus, or I'm sorry, minus 9x, and this one was gone, then you'd have to put a 0 in to fill that spot. But in this case, we can just put a 3, an 8, a negative 9, and a positive 2 here. And then we can bring down the 3. And again, now we go 1/3 times 3 is 1, or 3/3. And then we add, and again, if you were doing long division of these things, you subtract, but we're going to add. So 8 plus 1 is 9. Then we go 1/3 times 9 is 3. And then we add negative 9 plus 3 is negative 6. 1/3 times negative 6 is negative 2. Whoa, we got really lucky on this first one. Yes, 1/3 is a root. So x minus 1/3 is a factor. We got really lucky. I hardly ever get that lucky the first time. Usually I have to try 2 or 3 others. And I just want to say, if this one did not work, in other words, if we didn't get a 0 right here, you would just try something else. You know, normally it doesn't work the first time. That's amazing. 3, 8, negative. It's a 1 in 8 chance is what it is. And that's beating the odds pretty well. Normally, you'd try something, and over here when you're done, you'll get like a 4. You'll get not 0. Okay? Not 0 means not a root. Okay, if you get a remainder. Right there, you get a remainder, it means that negative 1/3 is not a root. You get a 0 here, that's a keeper. And sometimes you get a whole bunch of them, and you got to try several iterations of synthetic division to find it. We got really lucky. Okay, let's keep going. These numbers here are really, really, really important. Let's not lose them. Okay, so this means that x minus 1/3 times 3x squared plus 9x minus 6 equals, what did we start with? There it is. Equals 3x cubed plus 8x squared minus 9x plus 2. See, that's what we're saying, that 1/3 is a root. So x minus 1/3 is a factor times all this equals what we started with, our original. So now we're almost done. If we're trying to solve this thing, we're almost done. Because this is a quadratic, and you know, we know and love quadratics. They work great. First thing I always try is, I always try to say 3x squared plus 9x minus 6 equals 0. And then I try to say this equals 0. And I try to factor it. So what are the factors of 3x squared? Well, it's going to be 3x and x. What are the factors of, you know what, we can do better. I noticed this is a 3, a 9, and a 6. So we can factor out a 3. That'll make life easier. So we can say 3 times x squared plus 3x minus 2 equals 0. Now remember, the roots won't change, just the rate of change of the function. The roots won't change, so this is cool. So we can say 3 times this and double bubble it equals 0. Now we're just x and x, 2 and 1. Negative sign means one's positive and one's negative. Ooh, I can see already. This isn't going to work. Eek. It's not easily factorable. So at this point, we would have to solve it by some other method, and that's okay. Let's do 3x squared plus 9x minus 6 equals 0. Let's say a equals 3. I'm getting that right there, the x squared coefficient. And b equals 9. Getting that right there, the x coefficient. And c equals negative 6. Getting that right there, the constant term. So now we can plug that into, you guessed it. And at this point, Brian, if you have the program in your calculator, you can just run it. If not, you can do it by hand. Negative b over 2a plus and minus the square root of b squared minus 4ac. All that whole thing over 2a. Then we get negative 9 over 2 times 3 is 6. Plus and minus the square root of 9 squared is 81 minus 4 times 3 times negative 6 equal, no, over 2a again is 6. I do a little ciphering here. That reduces to negative 3 halves plus and minus the square root. That is 81, a negative plus 72, 15, 153 over 6. Now, Brian, you're looking at 153 and saying, that's crazy. There's no way. But I am looking at that and I'm saying 1 plus 5 is 6 and 6 plus 3 is 9. So I know that this guy is divisible by 3. Okay, and you can fiddle around with it a little bit. And in fact, I know this one. You would figure it out eventually, but just for fun, I'm going to say this is 9 times 17 over 6. And then further, I see that 9, and I'm all happy. I like that, because now I can say negative 3 halves plus and minus the square root of 9 times the square root of 17 over 6. And that is negative 3 halves plus and minus 3 times the square root of 17 over 6. And I can say negative 3 halves plus and minus. The 3 goes into 3 once, 3 goes into 3 twice. So that is the square root of 17 over 2. And so there we go. So, and we had an earlier one. The earlier one was 1/3. And there are the 3 roots, or the that we were looking for this. And then, just for grins, I think we should check it. So, well, square root of 17, that's a lot like the square root of 16, which is 4. 4 over 2 is about 2. So negative 3 halves plus 2 is about 1/2, about 0.5. Okay, and then negative 3 halves minus 2 is about negative 3.5. And then, of course, 1/3 is exactly 1/3. Okay, so for checking purposes, let's bring our calculator back and put this in. Got to turn it on. And put this in. I'm going to turn off my last one that I didn't need. Put this in. And what was the original problem? I can't even remember. Oh, here it is. It was 3x cubed plus 8x minus... No, I am goofing up here and I didn't even look. I didn't look up. Delete, 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 delete. 3x cubed. Get back there. This new OS is good, but sometimes it's a pain. Plus 8x squared. They're not going to fool me this time. Minus 9x plus 2. Okay, let me check it. 3x cubed plus 8x squared minus 9x plus 2. And that one I can probably just zoom standard and it'll get me pretty close. Okay, now, so we don't need much down here. We only need about 4 there, about 1 there. I'm going to change my window now. I'm going to start at -4, delete. I'm going to go to, what did I say? 0.5, just 1 should be fine, man. Delete. And I'm going to make a mark every, oh, 1's fine. And that one, negative, I don't know, not much. Maybe I'll go -1, lazy. And max of 1, sure, why not? And we don't need, alright, I guess I'll make a mark every 0.1. Okay, let's grab it. And we'll really be able to see this thing now. It should come down. There it is. There it is. Okay. So we have a root there, there, and there. Now let's check them real fast. Okay, second calc. 0 is for roots. Where am I? Left bound, -1.5. I guess I'm kind of in the middle. I want to go more negative because we had -3.5. Oh, I just saw it go by. Okay, that's fine. Enter. And I'm going to bring it back up. There, it just went past. Enter. Then I can go between these 2 points here. Pretty good, I think. I don't know. Should see it. There it is. See, it's real steep here, so it's blinking right there. It goes fast. And -3.56, and I said about. So that one checks. Because remember, I said it's 4 instead of a square root of 17, which is a little bit bigger than 4. So this should be a little bit bigger than, or a little bit smaller in this case, -3.5. So that's a keeper. And then you can check the other ones, Brian, but I can see they're okay. If this one's good, the other ones are going to be okay. That one is about a third, and that one is about a half, because there's 1. So we're good. We're good. You could check those. I don't want to bore you to death because I'm already, oh my gosh, I'm 33 minutes. This is the longest video I've ever done, but I guess you have time. So fast forward through the parts you know. Yeah. And that was cool, though. I liked it. So do we want to do one more? I don't know. Man, that's a lot. That's a lot. All right, one quick one. How about given a, because we haven't done anything with complex numbers, given a root of x equals 3, write a cubic equation with, I'll say in standard form because it's too easy the other way. In standard form with 2 complex roots. Maybe I shouldn't even say with 2 complex roots, but obviously it would be because it's a cubic. So there's 1, there's the others. Okay, so let's make it easy on ourselves. This one will go quick. I know you're probably bored, but okay. So a root of x equals 3 means it's a factor of what? X minus 3 is a factor. And then we just need 2 others. And so let's make it easy. It doesn't say they have to be um, exciting. So let's just say x minus I and x plus I to make our lives easy, okay, equals 0. So then we would say you want to do these two first because you're doing conjugate pairs like this, complex conjugates. They're going to come out nicely. So we're going to go x minus 3 times, okay, and again, you're going to go x times x and x times I, and then x times, or I times x and I times I, like that. All right, and then, so now we have x squared plus xi minus xi minus I squared. And when you see that I squared, remember, that's good. Good. That's a good thing because it helps us. So then we're going to have x minus 3 times x squared. Well, these guys subtract out. They're gone. And then I squared. Remember what I squared equals? Yes. I squared is negative 1. Watch your signs because it's minus. It's still there. And all of this is negative 1. So then that gives me x minus 3 times x squared plus 1. And then this one will have a complex root, but you won't be able to see it, which is what we want. So now I have x cubed plus x minus 3x squared minus 3. And again, I just multiplied that out. And you can use the FOIL method, or if you're more comfortable with the box method, go for that. It doesn't matter. You can go x and x squared and 1 and negative 3. You can go like that. X cubed minus 3x squared, like that, plus x minus 3, and put it together. It's fine either way. And so now we have x cubed minus 3x squared plus x minus 3 equals 0. Nice. And you're done. Okay, I kept it under 40 minutes. Oh yeah, that's long. But hopefully this is helpful for you. Stop it, take a break, go eat a sandwich halfway through because I know it is long. And get well and come back and do some retakes over 2.4 and 2.6. All right, that is all. Good night.